Hello everyone, we're going to now go through our video lecture on naming ionic compounds, learning the language of chemistry. How's that for a dramatic subtitle? Okay, naming ionic compounds. Remember, an ionic compound is one of the types of compounds that's held together by electrostatic attraction. So that's a positive and negative. We're talking about positives and negative charges when you're talking about ionic compounds. There must be a metal, which gives you your positive charged ion, and that's called a cation. And then there has to be a nonmetal, which is your negatively charged ion, called an anion. All right? And remember, just as a refresher, when, for example, an ion is created, when something like the chlorine atom gains an electron and becomes a negatively charged chloride ion. It's got an extra electron, so it's -1 charged. This is an ion. That could be an example of a nonmetal ion. All right, so we're going to learn how to name these ionic compounds. Okay, in order to name them, we have to figure out what kind of ionic compound it is. There are two types of ionic compounds. One is called a binary ionic compound. Of course, binary typically means two. And in a binary ionic compound, there are two ions present, one metal and one nonmetal. All right, so binary means two. The other type of compound is a ternary ionic compound. Ternary means three. So in this case, ternary refers to three or more elements present. In other words, typically this would be a metal and a polyatomic. Remember that list of polyatomic ions we saw on the back of the periodic table in the classroom? Polyatomics form ionic compounds, and specifically they form ternary ionic compounds. So there are different rules for naming these two types. Let's learn what they are. First, naming a binary ionic compound. In order to name a binary ionic compound, you first name the cation, which is the metal, the positive, and you use the same word as the element name. Okay, use the same word as the element name. And then second, you name the anion, which is the nonmetal, the negative part, but you change the ending of the element name to IDE. All right, let's see an example of what that looks like. A couple of examples. Okay, here's sodium and chlorine. Sodium is our positive cation, chlorine is our negative anion. When they form an ionic compound, this is the formula, NaCl. And so our rule said the first thing is you name the cation, so sodium, and then you name the anion, which is chlorine, but we change its ending to be IDE, so chloride. Sodium chloride, that's the name of this compound. Here's another example. This is made up of calcium and chlorine. The formula is CaCl2. And so first we name the cation, calcium, and then we name the anion, changing its ending to IDE, chloride, calcium chloride. Now notice there are two chlorines involved in this formula, CaCl2, because you need two chlorines with their -1 charge each to balance the two positive charges on calcium. So the formula is CaCl2, but the name doesn't say anything about 2. All right? So that'll come back again later. Here's our third example. Here's strontium, that's our cation, and nitrogen, that's our anion. The formula we're looking at is Sr3N2. How would we name that? Well, first, the rule says to name the cation, so strontium, and then we name the anion, changing its name to end with IDE. So nitrogen becomes nitride. So we have strontium nitride. Easy, right? Okay, now we're going to get lots of practice of this in class on Wednesday. So don't be distressed. We'll get good at this, I promise. Now let's look at naming ternary ionic compounds. This is the other type of ionic compound where there are three players. When you name ternary ionic compounds, the first part is just the same as last time. You first name the cation, which is the same name as the element. All right? That's just like before. But the second part of the name is different. Second, you name the polyatomic anion, and the ending will be different, depending. The ending is either ITE or ATE, and sometimes IDE. Well, how on earth are you supposed to know which it should be? It's on your polyatomic sheet that you will always have with you available in tests and exams in our classroom. Well, let's see some of examples because I think that's the best way to learn how to do this. Quickly first, this is a listing of all the types of ionic polyatomic ions that we deal with, or a subset actually. So, and you see their names are all end in ATE or ITE or occasionally IDE, just like I said on the previous slide. So this is the word that you use for the second part of the name. Let's see an example. NaNO3. This is a sodium ion and a nitrate ion. So the rule says to first name the cation, sodium, and then you name the polyatomic anion, making sure that the ending of the name is either ITE, ATE, or IDE. So this is sodium nitrate. Sodium nitrate. How about this one? CaCO3. Well, this is calcium, and this, we can look on the table, in case you don't remember, is carbonate. So the name is calcium carbonate. Finally, we have BaOH2. So Ba stands for barium, and this is the hydroxide ion, and so we name barium hydroxide. Again, notice it doesn't matter that there are two of these. And that's because with ionic compounds, you need to apply a little logic to the ionic compound. You have to know, for example, that barium is +2, and that hydroxide is -1. That means you must have two hydroxides in order to balance the barium. And so if you were only given the words, which we'll have some examples of that on worksheets, you can turn the words back into a formula just by knowing how many charges barium has and how many charges hydroxide has. So you don't need, the name itself doesn't need to have any reflection of this subscript 2. That's only important in the formula, not in the name. Okay, what's next? What about the transition metals? Because they're a little more complicated, right? You find those in the middle of the table. They have more than one possible charge state. They can be, for example, +2, +3, +4, whatever. How do we handle those? We use Roman numerals, and we saw this on the worksheet that we did in class today. So here's an example, iron 3 ion. The Roman numeral 3 tells you that this is iron in its +3 state. If this had been iron in its +2 state, it would have been iron with the Roman numeral 2, and we would know that that iron was a +2 state. Here, +3. All right, let's look at some examples. It's running backwards. Iron 3 oxide. So what would that formula look like? Let's work backwards, because that's what the slide is doing. It's what we call a mistake. So iron 3 oxide, we know iron is in its +3 state, and oxide will be oxygen. So that's Fe2O3. That's iron 3 oxide. Now you have to, when you say the name, you have to say the Roman numeral, because otherwise you don't know. Look at this one. Iron 2 oxide is FeO. All right, so the chemical formula for iron 2 oxide is FeO, and that means that iron here is in its +2 state. How did we know? Because it's paired with a single oxygen atom. All right, the single oxygen atom has -2 charge. That means the single iron that we see here in the formula must have a +2 charge. So this must be +2, this must be -2, this is iron 2 oxide. Here's another example, copper 2 nitrate. All right, that's a name. How would we get a formula out of that? Well, copper is in this +2 state, and we know that nitrate is -1, so we have two nitrates at -1 each, and one copper in its +2 state, CuNO3 2. All right? So like I said, we're going to get lots of practice with naming worksheets over the next couple of days, turning formulas into names and turning names into formulas. So stay tuned. It's going to be fun. That's it for now.